All right, we're going to be starting a brand new unit, just a little bit of a jump start on tomorrow's. Our objective today is that we will graph systems of linear equations and then estimate the solution. So we're going to start off with a system of equations. Essentially, anytime we have a system, we have a set, okay, with the same variable. So a set of equations with the same variable. Okay, so if you're dealing with x and y, you should have all x and y's, okay? And of course, we know that a set has two or more. Okay, so we're going to get into multiple equations. Maybe something that looks like this: y equals 3x plus 2 and 5x plus y equals 10. Okay? My counter example would be something like y equals 2x plus 10. And then you have like m equals b. Well, they don't have plus 5. These don't have the same variables, right? So that's my counter example. Even though there's more than one, they do not have the same variables. All right. The word consistent. This is going to be a set of equations, and I'll kind of show you what we mean here in a bit. A set of equations that has at least, that's one or more, at least one ordered pair that satisfies both equations. Okay, and visually what it's going to look like is something like this. So here's one equation, right? Drawn out, linear equation because it's a straight line. And then we have another linear equation, right? And there's only one ordered pair, one point that will make both of those equations correct. So only one point I can put in here for x and for y that will make both equations true. And that point would be located right there, okay? That would be the point. So this is what we call system. So basically a system of equations that has at least one ordered pair that satisfies both equations. So you got to have at least one. You could have two. Inconsistent might be something like this. You got two lines, right? And they're parallel, so they never ever touch. And that would not be consistent, right? Because you don't even have one single point, not one single ordered pair that satisfies both equations. So this would be my counter example. And everybody knows, right, by this point, over here on the side, these are all my counter examples. These are examples of what is not, okay? All right, let's get into independent. Any questions so far? Okay. All right, good. So independent is a system of equations that has exactly one solution. Okay? Only one. So right here, go ahead and share with me. How many solutions did we have in this right here? Now remember, solutions are where the lines touch. So how many times do they touch? Good. Okay. Anyone else? Yay. Good. All right. So this example here touches exactly one time. So not only, I guess, would this be consistent, but it is also independent. Okay. Let me redraw that last one. Kind of make it look a little bit like that one. Okay. So same thing, it's got exactly one solution. So right there's that solution. Now, what if I had something like this? Because we are going to be getting into the world of not just linear, but we might have quadratic, right? And so if I have a quadratic, it's going to end up looking like this. And then we could have a linear equation with that, right? And so it's consistent because it has at least one ordered. How many solutions does this have? Type it into your chat or tell me. Okay. Very nice. Good, 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 good. It has two, one right here and one right there. But is it independent? So this is an example for consistent. So these are both consistent. But if you said no, that it's not independent, you would be correct. Okay, let's say I've got a line like this. It's going like that. There's my two little points, right? This one can only have one solution. So this would not be independent, okay? All right, last one, dependent. Let's go into this. We have a system of equations that has an infinite, many, more than we can count, infinite number of solutions. Okay, and what happens here is, let's say I've got a line like this. I'm going to make it way bigger. Okay, and I'm going to put a little line on top of it. And here they are. They're like always touching. You see that? They're touching here, they're touching there, they're touching everywhere. It's like a little Dr. Seuss thing. Okay, so these are right on top of one another and they are constantly touching. And it's like that one dependent couple that you might know, right? They're constantly together, like they would die if they were apart from one another. So that's what dependent is. When you have two equations, two systems, you have two equations that are constantly on top of one another, they have infinite number of solutions, okay? Infinite solutions. All right, last one. Go ahead. And here we are, inconsistent. It's a system of equations. And it's a system of equations with no ordered pairs. Okay, that satisfy both equations. Okay, otherwise known as no solution, which means that they don't touch, right? So no intersecting. So essentially parallel lines, right? And we're going to pretend that those are perfectly parallel. And then here, my counter example for inconsistent would be any two lines that touch like that. That's okay, so that's, so this right here is inconsistent. And here I have dependent. So again, a system has an infinite number of solutions. This again would be counter examples. It has one solution, not infinite, right? Or you could even have parallel lines there, right? And the way I like to think about this right here, the way I try to remember about inconsistent, this might be a little dark, but if somebody is inconsistent in your life, are they there for you? No, right? Just like these two lines, they both exist, but they're never there for one another. They never ever meet, right? That's inconsistent, okay? Dependent is when they're like, can't breathe, can't ever do anything without one another, right? Dependent, two lines right on top of one another. Independent is, you know what? I think pretty healthy, right? They both do their own thing, but they meet up once in a while. They touch once, right? And then consistent can be, you know what? They meet up once, maybe they meet up more than once, okay? So kind of keep that in mind. All right, ladies and gentlemen, we're gonna take a break. All right, so let's go ahead and let's talk about the three basic types of graphs that we're gonna have, okay? Anytime we have a system, we have more than one graph, and these are the basic configurations. Here we go. All right. So the first one here in this graph, under the chat if solutions live where lines touch, how many solutions do I have there? Go ahead and put it in the chat real quick, or you can just yell it out or tell me. Okay, let's go. Pause. Yes, I can. So I got a couple of different answers, and the correct answer is once. Here you have one single time that they're touching, right? So you have one solution, okay? You have one solution. Okay, let's try that again. So I've got this other situation, and you can't really tell from the drawing here, but you got one line, and then you have another line right on top of it, okay? Go ahead in the chat, tell me, how many solutions do you think we have? Remember, they're right on top of one another. I'm going to try and make it a little bit bigger there. So go ahead and put that in the chat for me. How many solutions do you think there are if it's one line right on top of the other? Oh, actually, I almost want to say, there we go. Yay. All right. I was going to say none was kind of the closest answer, and in fact that it was like actually opposite. So how many times do these touch? Well, they touch here, and they touch there, and they touch here, and all over, right? Everywhere. Everywhere they're touching, more times than we can count. So this is actually infinite. Good job, sir. Got it. Infinite. Make that a little skinnier. Infinite solutions. Okay. And here we're going to have this last one. We have parallel lines. Go ahead and tell me, how many times do they touch? Keep in mind, sometimes we say infinite and we'll use this. Yay, good. Okay, much better on that one. We know from middle school that parallel lines do not touch. Therefore, there is no solution, okay? Or otherwise known as zero solutions. Yes? No solution or zero solutions. Either way, I was good. Okay, good. All right, so we have very special names for these, and as we get into the definitions, we will kind of talk about it. So just to let you know, let's look at consistent. Consistent, again, has at least one ordered pair that satisfies both equations. So they touch at least once, right? So that's basically the message here. Here, this one touched one time, this one touched two times. So when I go down here, and that word was consistent. Okay, so has to touch at least once. Is this consistent? Does it touch at least once? Let me know how. All right. Yeah. This is consistent. Let's see if I can spell. It's kind of early for spelling. All right, consistent. Okay. How about this one? How about the infinite solutions graph with the two lines right on top of each other? Are they consistent? Yes. Good. Leave a little room because we're going to write some more stuff in there too. All right. And this last one, are these consistent? Do they touch at least once? Good. Okay. So this is the opposite of consistent when we look at these words. Opposite of consistent is inconsistent, right? This is opposite. Okay. No intersecting. Okay. So I would definitely put inconsistent. All right. And then let's talk about the next one, independent and dependent. So let's look at them again. Let's look at our definitions. Independent is when you have exactly one solution, right? And dependent is when you have infinite number of solutions, right? So it's either one or infinite. So when I look at this first graph, is this independent? You can put Y or N. That way you don't have to type so much. All right, it is. It is independent. So consistent and independent. All right. This one, it's consistent and it is, let's see, is it independent? Yes or no? Good. So I got good memories. Okay, it's not. It's actually dependent, right? Because it's got infinite. So it is consistent and dependent. And then let's look at this one. What do you think? Is it independent, dependent, or neither? All right. Good, 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 good. It is exactly. It is neither. It is simply inconsistent, okay? All right, guys, so that wraps up vocabulary today. And tomorrow we're going to be picking up with example 1 and going through the rest of the lesson. So have a great day. Take care. Bye-bye.